In this video, I'm going to formalize the method that we have been using for adding vectors. So far, we've been doing it pretty intuitively in one dimension, and it's fairly simple. However, when we start to do two dimensions, it'll get a little more complicated. So the method that we use for adding vectors is called tail-to-tip method. So if I were to say go to the right a distance of 5 meters, okay, I would draw my vector like this, so along the positive x-axis. And then let's say along the positive x-axis, I go then 3 meters. So if I were to draw this vector, it would make sense for me to place it right here, right? This is the tail to tip method. So I have placed the tail of the second vector at the tip of the previous. And I could do this on and on with however many vectors I had, but let's just do it with 2 to start. And it will give me my resultant. And then my resultant vector is placed from the tail of the first vector to the tip of the last, which is really sort of commonplace when thinking about something in one dimension or even in 2 dimensions if we're talking about displacement. Right? So my resultant vector would be this, from where I originally started to where I ended up, or a positive 8 meters, right? Now let's say I go 5 meters, I have a vector that's 5 meters to the right, and a vector that is 3 meters to the left. Well, if I were to draw that, so I've got my 5 meter vector first, and then 3 meters to the left, and so in vectors we make that a negative 3 meters. And so then if I was to draw my resultant vector, it would be from the tail of the first to the tip of the last vector. Right? Which would, if I were to add that together, would be easily just 2 meters. Right? So it's very intuitive when we do this in one dimension in the x or the y direction. And then we can just simply add the numbers together. Now, another thing that I want you to keep in mind about tail-to-tip method is it doesn't matter what order you place the vectors. You can place them in any order that they appear, and we will still get the same resultant. You can also pick vectors up and move them around in space. As long as you don't change their size or direction, we'll always get the same resultant vector. So this might seem super commonplace here, or kind of like, why is she even saying this? If I were to take, say, the 3 meter and place that first, and then take the 5 meter vector and place it afterwards, if we looked at our resultants, they would be exactly the same, or 8 meters. Okay? So this is really straightforward one-dimensional addition of vectors. In the next video, I'll go into detail the same concepts using the tail-to-tip method and combining that with our component method to do two-dimensional vectors.